Hello everyone and welcome to this section. In this section we're going to build our simple perceptron model, okay? Here we're not going to train the network in any way. Here we're just going to show you how to build it first. And then in the next section we're going to learn how to do what we call backpropagation, which is kind of a training technique that we can use. And then in the next section we're going to actually show you how can we take that network, take the exact same code and train it, okay? And train the network. All right, so let's get started. So first, import pandas as PD. That can be used to import pandas library, which is kind of can be used to perform a lot of data frame manipulations, which is very similar to kind of Excel per se. All right, and then we're going to import NumPy as MP. That's for numerical analysis, and then import matplotlib as PLT, which can be used to mainly obviously for plotting different data. And then we're going to import a very powerful library as well, so we'll call it Seaborn as SNS. And that can be used to, again, plotting, but mainly for statistical analysis plotting. I'm going to show you how can we use it as well. All right. And then what we're going to do here is we're going to use Keras, okay, and TensorFlow to simply build our artificial neural network. Keras makes our life 10 times easier than actually building it, either, like from scratch, or using TensorFlow. Keras kind of, lives on top of TensorFlow and can make, our life much easier. I'm going to show you how can we build a network. Again, this kind of a code that build our network in a very simple form, which is, let's say 10 or 15 lines of code, okay? So what we're going to do is we're going to import, first of all, let's run cell by cell. So let's run this cell first. So we're going to press Shift and Enter. And once you show a number here, that means we ran, we're good. And then the next step is we're going to import TensorFlow.keras, all right? And then what we're going to do is we're going to import what we call it sequential. So import keras.model, import sequential and dense. All right. And I'm going to show you exactly why do we need to do this and how can we actually use it to build our network. Okay. The next step is that we're going to read our data. Okay, so here we have an Excel sheet, which we call it speed decision data. Again, this data is kind of, fake data, can be used just for classification, which shows us, how our truck bump example in a way, okay? So let's run this cell, okay? So it's running, all right, and then we're good. And then let's take a look at the speed data. Let's see what's in there. So when we say speed_data.head, that will simply can show us the first couple of lines or couple of segments within our sheet or the data that we just loaded. So first we have our 1 minus distance from the bump, okay? That's the first column. And then we have our height of the bump, okay, here. And then we have our speed. So simply speed 0 or 1 indicating, okay, are we slow or are we fast? In a very simple form. These are kind of the two classes or the two decisions that we need to take based on our data, okay? Based on the height of the bump and based on the distance or 1 minus distance away from the bump, okay? All right, so we're good. The next step is we wanted to simply plot, okay, let's take a look at the data. I'm gonna plot the first column, which is the first kind of input. I'm gonna plot the second input, and we're gonna plot the speed simply as kind of color that shows us pretty much the different classes as two different colors, okay? So what we're going to use what we call a scatter plot, okay, which is kind of like a method within the SNS library. And what we're going to do, we're going to use the speed_data, and then we're going to write the first column, which is 1 minus distance from bump, and then we're going to write the second column, which is speed_data, height of bump, and then we're going to use hue, which can be used to actually indicate the colors, okay, which class we're going to be showing. So here I'm going to show, okay, speed_data, and then we're going to use the speed. It has to perfectly match, obviously, our speed value here. Okay. All right. So let's run this, and that's pretty much the data that we showed you in our lecture. Again, here that shows 1 minus distance from the bump. Okay, and here we show the height of the bump in a very simple form. All right. So if you guys recall that we had this data pretty much, it's exactly the same data that we had. So simply if our bump is high, okay, that means the speed of the vehicle, we're going to set it to low. And if we are near the bump, if the truck is very close to our bump, that means again our speed is going to be low. On the other hand, if our height of the bump is low, and we are far away from, if the truck is far away from the bump, then our speed is going to be fast. All right, and that's kind of the two classes we're going to be talking about. Okay, and that's pretty much the exact same graph that we had. All right, so the next step is we wanted, okay, for example, to, let's say we wanted, as we mentioned, to plot the data. Okay, so we plot the data. Now it looks great. The second step is that we wanted to load the data, load the two columns, and put them in the, what we call it, X-train. And that's the portion, the first training part of our model. So the model, our model has two inputs, okay, which is again the distance, or 1 minus distance of the bump and the height of the bump. And that's why we got the speed data. And then we got the first two columns, which is the first, this is the first column, this is the second column. And we put that in X-train. Okay, let's run it. So we're good. And then the next step is we're gonna get again speed data, and we're gonna get the third column, which is our target class speed, and then we're gonna put it in Y-train. All right, let's run it. Okay, we're good. And now to the fun part. Now we want to actually build our model. Okay, so if you guys recall, what we're gonna do here is just gonna build one neural model. Okay, so the model, our model has two inputs, one bias, if you guys recall, and then we have our output. Okay, so in order to build the model, we're gonna build the model in what we call it sequential fashion, or sequential form in Keras, layer by layer. That's what we're gonna do. We're gonna build the input layer first, next layer hidden layer, third hidden layer if there is any, and then the output layer moving forward. So first we're gonna call model, that's model equals sequential, that's the first step. And then on that model, we're gonna start adding different layers. So the next step is, the next command is we're gonna call it model.add. And then we're gonna call it dense. When we say dense, that means we're just gonna have a fully connected layer. So all the layers, for example, in the input, which is our two, all of them are gonna be connected to our neuron, which is in this case, gonna be the output because we don't have any hidden neurons. So we're gonna call it dense, all right? And what we're gonna do is we're gonna define input dimensions equal to, so we have two inputs, and our activation function too, if you guys recall. So we can define if it's ReLU, if it's like, like a hyperbolic, like tangent function, or if it's sigmoid function. So here we define it as sigmoid function, all right? And that's pretty much how we build our model in a very simple form. Again, this section, we're not gonna train it per se. Here, we're just gonna build it first. And then the next step, we're gonna discuss training techniques. How can we actually train it, and from an intuition perspective? We're just gonna see the intuition of what we call a backpropagation technique. And then afterwards, we're gonna take the exact same code, add a couple of lines of code to actually train it, and then let's see the results of this, all right? So let's run this cell. Okay, we're good. And let's take a look at the summary. So there's like an amazing method that you guys can use, just model.summary, that can tell us kind of, summary of our model, how many tunable parameters, how many layers, and so on. So let's run this. And it's pretty interesting. So you guys can see here we have our total parameters, or our trainable parameters are 3, which is very important. So the question is, okay, why 3? So if you guys recall, again, we have two inputs only. Why 3? Because we have a bias signal. So we have two inputs, we have two weights, right? And that's the actual tunable or adjustable parameters. The inputs are that's the training data, it's a different story. Here we have two weights, okay? And we have a bias signal. So in each neuron, we have actually 3 kind of adjustable parameters. That's why we have kind of a dense function. Our output, we're gonna be 1, and we have 3 parameters, which is 2 weights and 1 bias. All right, so let's take a look at what if you wanna see, for example, the initialization of our weights and biases. What we could do is that we can use model, okay, dot layers 0. That means we're talking about the first layer, which is in this case the input layer. And we want to say what we call it get weights. When we say get weights, we just want to get, okay, what weights we have. And then this basically we're going to return to us our weights and our biases, all right? And then we're just simply going to plot our weights and our biases. Let's run it. And let's run the weights. And that will tell me, okay, these are the actual initialization of our weights. So weight 1 is actually 0.321. Weight 2 is minus 0.23. That's kind of initialization. And actually kind of take a look at the bias as well. And the bias is defined as 0 in the beginning. This is kind of an initialization of our model. All right. And that's pretty much all what we have. Again, just to recoup. So what we did first, we loaded all the libraries in here. The next step is that we imported all the sequential and dense mainly. And we loaded the data. Here we viewed the data. And then we plotted the data using scatter plot, the Seaborn. And then we defined the training data, X train and Y train. And then afterwards, we actually build our model in a sequential fashion, which is just one simple neuron. There's no model. It's a very simple model, obviously. And then here we got the summary of the model, and then we got the biases and weights, just kind of to get an idea of the initialization, all right? And that's pretty much all what I have for this section. I hope you guys enjoyed it, and see you in the next section.